Hi, boys and girls. Today is Thursday, April 30th, and you're going to be doing a lesson 11-3, which is combined volume. Now, one thing you want to remember about volume is what we covered for the past 2 days, which is volume is length times width times height. So now today you're going to be finding the volume of a combined figure. That means that it's basically two separate figures that have been put together. So what I like to think about is that when I'm looking at a figure, I want to note which side is the length, which side is the width, and which side is the height. So for instance, let's look at figure A here. I labeled this figure A because originally these two figures were stacked on top of each other, but I kind of cut them so that they're separate, okay? So now if you look at figure A, I labeled the length is right here, okay? And if you look over here, the length is usually the side that runs across back and forth like this line. The width, okay, is the side that runs slanted back, okay? So if you look, this is the width, kind of like these slanted or diagonal lines. And lastly, your height is the side that runs up and down. So here you can see this is your height, all right? So if we look at figure A, okay, because I've cut this figure and I've labeled the bottom one A and the top one B. Now if I use my formula that we've been using this week, if I look, the length or this side that's going across is 10 meters. And here I've put it, length is 10 meters. The width or this side that's running back, slanted back, is 9 meters. Okay, so here's my width is 9 meters. And my height, or the side that's running up and down, is 7 meters. So now if I use my formula that, which is volume is equal to length times width times height, then the volume for figure B would be 10 times 9 times 7. And if I do 10 times 9 times 7, I get 630 cubic meters. So now I found the volume of figure A. But now I got to go back and I got to find the volume of figure B. Okay, so again, this is a little bit more challenging because I have to look at this. That's why I'm saying follow the side that runs across for your length. Okay, and if you notice, there's no number here. Okay, but if you go back over here, here's your length. Okay, and if you look, the bottom figure, the whole length was 10, and from here to here is 6. So if you added 4, that would give you your 10, okay? But again, that's this whole length, but I only want this side, okay? So if I look, this length is 4, and that's why 4 meters, that's why I have it here. My width, or my side that goes backwards, is 9 meters. So here I have it listed as 9 meters. And lastly, this side running up and down is my height is 5 meters. So here I have listed it as 5 meters. So my volume for figure B is the length of the 4 times the width, which is the 9, times the height, which is the 5, and I get 180 cubic meters. But that's the volume of these two figures separately. I want to find what's the total volume of this entire figure. Well, I just found the volume of figure A, and I just found the volume of figure B. So to find the total volume of both figures A and B, I just add these two volumes together. So we just found out that the volume of figure A was 630 cubic meters, and the volume of figure B was 180 cubic meters. So all I'm going to do is I'm going to add these two volumes together. So 630 cubic meters plus 180 cubic meters is going to equal 810 cubic meters. So the total volume for this entire figure here is 810 cubic meters. And I added a little note here. You want to remember that the answer is called cubic. I'm using the unit answer of cubic because think of a cube. We know that it's three-dimensional, okay? And I'm using 3 numbers here, okay? That means I'm using 3 dimensions, length, width, and height. Okay, I hope this helps you, and I hope you have a great day, and good luck on your practice buddy and quick check. 9th.